This is the fifth type of special product, which is known as square of quadrinomial, where square of quadrinomial is equal to the sum of the square of the first four terms, first, second, third, and the last term, and the fifth term can be defined as twice the product of the first and the second term. Sixth term is twice the product of the first and the third term. The seventh term is twice the product of the first and the last term. The eighth term is twice the product of the second term and the third term. The ninth term is the product of the second term and the last term, and the third term of the square of quadrinomial is twice the product of the third term and the last term. So this is known as the formula of any four terms of a polynomial which is to be square. Now, where did this formula come from? Or where do this formula derive? Now, this formula derived from the longhand method, or which is known as the traditional method or conventional method. So when we square quadrinomial, that can also be written as a plus b plus c plus d multiplied by itself, which is also the same as a plus b plus c plus d. So what we will do is to multiply the second polynomial by the first polynomial using the longhand method. So let's work on this. So a times a, so we have a square, and then a times b, so we have positive ab. A times c, so we have positive ac. A times d, so we have positive ad. And then multiply the second term by each term of the first polynomial. So we have b times a, so we have ab. B times b, so we have positive b square. B times c, so we have positive bc. B times d, so we have positive bd. And then next step is we multiply c by the first term of each polynomial. C times a, so we have positive ac. Then c times b, so we have positive bc. And then c times c, so we have positive c square. And then c times d, so we have positive cd. And the last term is to be multiplied by each term of the first polynomial. D times a, so we have positive ad. D times b, so we have positive bd. And d times c, so we have positive cd. And the last term we have d times d, so we have positive d square. So simplifying it now, so we have a square, 1ab plus 1ab, so that is positive 2ab. 1ac plus positive 1ac, so that is 2ac. 1ad plus 1ad, so that's equal to positive 2ad. Then we have the positive b square. 1bc plus 1bc, so that is 2bc. Plus 1bd plus 1bd, so that is 2bd. Then we have positive c square. 1cd plus 1cd, so that is 2cd. And the last term we have d square. Now we can rearrange the term in order. The first four terms should be perfect square, so we have a square. And we have positive b square. And we have the c square. And we have the fourth term, which is d square. So this is d square. And then the fifth term should be 2ab. And then we have 2ac. And then we have 2ad. And then we have 2bc. And we have 2bd. And the last term should be 2cd. And that is very much the same as this formula. Now, if we take a glance at this formula, you will clearly see three things or a pattern in the product. So this is it. The product composed of 10 terms, or the product consists of 10 terms. So let us count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The second thing is the first four terms are all perfect square. So these are the perfect square. The first four terms, a square, b square, c square, d square. And then the third thing The last 6 terms are all even numbers. So we have the last 6 terms, 2AB, 2AC, 2AD, 2BC, 2BD, 2CD. Since these numbers are multiplied by 2, any number multiplied by 2 are all even numbers. Now let's have an example to illustrate the application of how to find the product of square of quadrinomial. So let's start with problem number 1. Find the product of 3m minus 2n plus 5p minus q raised to square. So the first one is we need to square the first 4 term. So square 3m, that is positive 9m square. Negative 2n times negative 2n, so that is positive 4n square. 5p times 5p, so that is 25p square. Negative q times negative q, so that is positive q square. Now to find the first term, so that is twice the product of the first and the second term. So we have the first and the second term, then multiply it by 2, so we have 3m times negative 2n, so that is negative 6mn times 2, so that is negative 12mn. And then for the sixth term, we have twice the product of the first and the third term. So we have 3m times 5p, so that is 15mp times 2, so that is positive 30mp. And then for the seventh term, so we have the first term times the last term, so we have 3m times negative q, so that is negative 3mq times 2, so that is negative 6mq. And then for the eighth term, so we have negative 2n times positive 5p, so that is negative 10np times 2, so that is negative 20np. And then for the last term, for the ninth term, we have negative 2n times negative q, so that is equal to positive 2nq times 2, so that is positive 4nq. And then the last we have is 5p times negative q, so that is negative 5pq times 2, so that is negative 10 PQ. For the next one, we have the quantity of 4x plus 2y minus 3c plus 5 raised to square. So squaring the first term, so we have 4x times 4x, so that is 16x squared. For the second term, we have 2y times 2y, so we have positive 4y squared. Negative 3c times negative 3c, so that is positive 9c squared. 5 by 5, so that is positive 25, we should say. And then for the fifth term, so we have 4x times 2y, so we have 8xy times 2, so that is 16xy. 4x times negative 3c, so that is negative 12xc, multiplied by 2, so that is equal to negative 24xc. 4x times 5, so we have 20x times 2, so that is 40x. And then 2y times negative 3c, so that's equal to negative 6yc times 2, so that is negative 12yc. And then 2y times 5, so that is equal to 10y times 2, so that is 20y. And then the last we have negative 3c times 5, so that is negative 15c times 2, so that is negative 30c. Next problem we have is the quantity of 4a5 minus 3b cubed plus 5c minus 6d7 raised to square. Squaring the first term, so we have 4a5 times 4a5, so that is positive 16a10. Negative 3b cubed times negative 3b cubed, so that is positive 9b6. 5c times 5c, so that is positive 25c squared. Negative 6d7 times negative 6d7, so that is positive 36d14. Now to obtain the fifth term, so we have twice the product of the first and the second term. So 4a5 times negative 3b cubed, so that is negative 12a5b cubed times 2, so that is negative 24a5b cubed. Then 4a5 times 5c, so that is 20a5c times 2, so that is positive 40a5c. 4a5 times negative 6, 7, so that is negative 24, a5 d7 times 2, so that is negative 48, a5 d7. Then we have the second term multiplied by the third term, so we have negative 3 times positive 5c, so that is negative 15 b cubed c times 2, so that is negative 30 b cubed c. Negative 3b cubed times negative 6d7, so that is positive 18b cubed d7 times 2, so that is positive 36b cubed d7. And then we have 5c for the last term, so we have 5c times negative 6, so that is negative 30 cd7 times 2, so that is negative 60 cd7. For problem number 4, so we have the quantity of x12 plus 7y4 minus 8c8 minus 10 raised to square. So the first term is x12 times x12, so we have x24. 7y4 times 7y4, so that's positive 49y8. Negative 8c8 times negative 8c8, so that is positive 64c16. And the fourth term, we have negative 10 by negative 10, so that is positive 100. Now to find the fifth term, so we have x12 times 7y4, so that is 7x12y4 times 2, so that is 14x12y4. x12 times negative 8c8, so that is equal to 8x12c8 multiplied by 2, so that is negative 16x12c8. And then multiply the first by the last term, so we have negative 10 times x12, so that is negative 10x12 times 2, so that is negative 20x12. And then for the second term times third term, so we have 7 times negative 8, so that is negative 56 y4c8 times 2, so that's equal to 112 y4c8. 7y4 times negative 10, so that is negative 70y4 times 2, so that is negative 140y4. And the last we have negative 8c8 times negative 10, so that is equal to positive 80 times 2, so that is 160c8. And then the last problem we have is the number 5, which is 3m minus 5n minus 4p plus 7q raised to square. So the first term is 3m by 3m, so that's equal to positive 9m square. Negative 5n by negative 5n, so understood to be positive 25n square. Negative 4p times negative 4p, so that is positive 16p square. And the last term or the fourth term is 7q by 7q, so that is positive 49q square. Now for the fifth term, so we have 3m times negative 5 times 2, so that is equal to negative 30mn. 3m times negative 4p, so that is negative 12mp times 2, so that is negative 24mp. 3m times 7q, so that is 21mq times 2, so that is positive 42mq. Negative 5n times negative 4p, so that is positive 20np times 2, so that is positive 40np. Negative 5n times 7q, so that is negative 35nq times 2, so that is negative 70nq. And then we have the last term, negative 4p times 7q, so that is negative 28pq times 2, so that is 56pq. Now to summarize it all, as you notice, the product composed of 10 terms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it composed of 10 terms. For the second problem, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 terms. Problem number 3, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now the first 4 terms are all perfect square. 9, 4, 25, 1 are perfect square. 16, 4, 9, 25 are all perfect squares. 16, 9, 25 are all perfect squares. Same thing with 36. and the last 6 terms are all even number. So these are the last 6 terms for problem number 1. 12, 30, 6, 20, 4, and 10 are all even numbers. And then for number 2, the last 6 terms are also even number. So 16, 24, 40, 12, 20, 30 are all even number. For number 3, 24, 40, 48, 30, 36, 60 are all even number. That checks our solution. For 4 and 5, for number 4, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It composed of 10 terms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. For number 5, consists of 10 terms again. Now, for the first 4 terms are all perfect square. So, 1, 49, 64, 100 are perfect square. 9, 25, 16, 49 are all perfect square. Now, for the last 6 terms are all even number. So, we have the last 6 term for the first, for the number 4 problem. So, we have 14, 16, 20, 112, 140, 160 are all even numbers. For number 5, we have 30, 24, 42, 40, 70, 56 are all even numbers.